Hello and welcome to today's explanation about breadboards used in electronics.
Originally, electronic breadboards were actually mounted on wood. That's why they called them breadboards. People would take slabs of wood, just like they'd cut a loaf of bread on, and drill holes through them to mount the components. These are pictures of early radios from the 1920s, mounted on boards.
As things got more complicated in electronics, they used wire wrapping, just wrapping wires from point to point, wrapping around metal posts, poking through the boards. But it's not an easy solution. Something needed to be better. Then in the early 1970s, somebody patented the solderless breadboard and changed how electronics is done forever.
The modern breadboard looks like this. It has columns and rows of holes that are connected electrically with strips of metal underneath the holes so that you can plug in components, build a circuit, and test it to see if it works before you build it permanently.
This is an example of some modern breadboards. Usually they're white plastic, but some are transparent or different colors. They come in large sizes or standard, half size, and mini boards. Most of the boards are built so that they have little tabs on the side so you can snap them together and create larger boards. If you look more closely at an individual board, they're numbered with rows and lettered with columns. They're built so that you can plug the leads in of components, and it holds them in place strong enough so that it's not just going to fall out, but loose enough so that you can easily remove it and move it to a new location if you need to. Technically they're called solderless breadboards because they don't need solder, they don't use solder, but most people just refer to them as breadboards. If you look underneath the board, this explains how they work. On the back is usually an adhesive back so that you can like stick them to projects if you need to do that. And if you peel off the backing, which don't do because then it makes it hard to make it work, but just to show you how it works, there's a little metal tabs, little clips. If you take one out, like if we poke it out and remove it, you can see magnified up a little metal clip. There's 5 clips in a row, and the leads from your components go into the clip, and it's the clips that hold them in place. So good quality boards have good clips that will continue to hold in place. Cheaper boards, the worst is getting a cheap board with a clip that doesn't really hold, or after a few times you plug it in it just wears out and they just don't work. Now notice the metal strips on the back. The 5 clips are in rows separated in the middle by a little plastic divider. Again, the clips need to hold tightly. The rows and columns help you specify where things need to be built. So the columns are labeled A through J, and the rows 1 through whatever number, however big your board is. So for example, column C, all of those highlighted are in the same column C. All of these highlighted are in the same row 12. So you can specify location, like in Battleship, C12. And on the sides of the board are the rails, or power rails. Often they're shown by a red line and blue line or a black line, often with plus and minus signs. It doesn't mean you have to plug in your positive and negative leads there. It just means if you do, you'll have a positive rail and a negative rail for the whole length of the board. Now some boards have a little split halfway down the board, and so you got to be aware that if you have a split board, you'll need to use a jumper wire to connect the top of the rail to the bottom of the rail. A variety of jumper wires can be used to connect points on a breadboard. These jumper wires have just the insulation removed from each end. These have reinforced ends. Various colors can be used to help you more easily keep track of things. This is a view of components and jumper wires connected on a final breadboard. Thanks, hope you learned a lot. Have a great day.